So our first step after receiving the material is pre-processing it. As I mentioned, for wet AD, there'll be a lot more contamination reduction in the pre-processing step. For dry, stackable, or slurry systems, there'll be more at the back end. But for both of them, we want to have a nice homogeneous mixture going into our process. So we have material coming from a bunch of different sources, and we want to have it blended to make a recipe that's going to make our microbes happy and be suitable to the technology we're using. So we want our pH to be neutral, our carbon to nitrogen to be around 25 to 30 to 1, our moisture content to be in whatever zone is appropriate for the technology we're applying, and then however much contamination reduction is required by our particular approach, depending on the technology. So in a dry system, there's not too much we'll do at the front end. Definitely as the waste is being unloaded from trucks and then loaded into the equipment, they'll be inspecting it for any large contamination that's going to damage the equipment down the line. So any like really big tree branches and things like that. If if food comes in bags, they'll want to open those bags. They'll probably want to grind and shred the waste a little bit just so there's more surface area to work with. And you maybe do a little bit of contamination reduction with a screen or a trommel. So just sorting things by size, or with a magnet, which might pull some of the metals out at this stage. With our wet waste, we'll have a lot more intensive pre-processing. So there's kind of three fractions that we want to take out. There's a floating fraction, so like our plastics. There's a sinking or heavy fraction, like metal and stones. And then there's a suspended fraction of inorganic grit and glass and things like eggshells that they don't sink or float, but we still don't want them in the process. And there's kind of three technologies that kick us off in this wet waste pre-processing process: a hammermill, a press, and a pulper. So a lot of the anaerobic digestion pre-processing technologies work a lot like things that you might find in your kitchen. So to demonstrate, the easiest one, or the most similar one, is probably the hydraulic press, which works a lot like a garlic press. So I'm going to take a handful of garlic with the skin on and some of the bottoms and stems. We're going to pop it in. And this is kind of an analog to a mixture of the nice wet organic waste and then the fragments of plastic and glass and paper and stuff that would also be going in. So if we press this, you can see our organics are extruding out this side, and they're pretty clean. And if we look inside, we've retained a lot of this papery stuff and the harder stuff over here that we don't want in our system. The second pre-processing technology is the pulper, which is a lot like a blender. So again, I'm going to take some whole garlic with the skins on them. We're going to add a little bit of water because there would be some moisture in the process. So coming out of this process, you can see that a lot of the organic is actually dissolved in suspension, which is good. And you can also see in here that a lot of the skins have separated. So if I scrape some of these solids out and put them down, you can see the skins have come away from the centers. And this stuff will be separated out later in the process, but it's been separated from the nice juicy organic stuff that we want by pulping it together in this step. So the last approach is the hammermill, and this one there's not really a great kitchen analog for it, even though it is a bit of a combination of the other two, the press and the pulper. So in the hammermill there's a few things happening. So firstly, there's spinning hammers that are crushing our organics and making them into small pieces. So I'm just going to crush our organics with our hammer here. So this is kind of similar to what was going on in the press with the pressure. And you can see that we've had some separation of kind of our dry piece representing our contamination and our nice wet juicy organics. In the hammermill itself, this wouldn't be happening on a flat surface. It would be happening while spinning around inside of a drum with holes in it. So I'm going to put all my material into this sieve here. And you can picture in the Hammermill, there's this pressure pushing against the outside, and there's this force driving our organics against the side. And you can see that some of the material is pressing through here. And if I kept doing this for long enough, I'd actually push all my garlic through the outside, and I'd just be left with the dry stuff on the inside. And that's kind of what's going on in the Hammermill. So it's kind of like the press, but in a rotating plane. And it's kind of like the pulper because it's wet and it's spinning around as well. So those demonstrations are admittedly clumsy. It doesn't really make sense if you were cooking to try and start cooking before you peeled your garlic. So the alternative to using pre-processing to remove contamination is actually just make sure that your waste system users are going to be reducing the contamination at the source. So if we had people who would peel their garlic, then we'd be throwing the nice clean garlic in the system. We wouldn't need those intensive processes to try and separate them, which is always a little bit clumsy at the facility. So for my last kitchen demonstration, I just wanted to touch on the philosophy of doing the pre-processing to remove the contamination versus post-processing to remove contamination. So if you were to look at these two piles of rice and beans, this is uncooked and dry. This is cooked and wet. Which one would you think would be easier to automate separating the rice and beans in? To me, it seems like this one is a lot easier. I can just come in with like a simple straining device like this fork and do a pretty good job at separating. If I try and do the same thing over here, I just can't apply the same principles. It's all wet and stuck together. So this is kind of the difference between a wet AD process would take this mush and subject it to a press or a Hammermill or a Pulper to try and separate the two out, whereas a dry process will let it all go through. At the end, you'll get something that's more dry and stable, especially if you're composting it, and then it's easier to come along and sift out the contamination at the back end of the process. So there you have our three main pre-processing technologies as applied to awkwardly peel garlic. Our pulper is like our blender. We're going to rip things up, suspend them in water, and then we're going to get our peels coming off and floating up. And then if there's anything heavy, it's going to go to the bottom, and we'll have this slurry in the middle to pipe off. This press where we're going to squeeze everything, squish through all the squishy organic stuff, and keep all the larger contamination that's not going to squish through as easily on the screen. And then our Hammermill, we're going to beat everything up like I did with the hammer, and then spin it around and force it centrifugally through these little holes, like me pushing it through the sieve. So all those processes are accomplishing a few things at once, but they all have opportunities to let some contamination through, especially the grit fraction. So some steps that might follow that initial core treatment are a dynamic cyclone, or for grit removal, a hydrocyclone, gravity separation, or an in-tank removal system. So dynamic cyclone actually operates a lot like the Hammermill. So we're spinning the material around and forcing it through a screen. With the dynamic cyclone, the real focus is on that centrifugal force and forcing it through the screen, whereas the Hammermill, we were trying to beat up the material as well as a major function. But it kind of just repeats that and pushes our organics through and holds our contamination on the screen. Now the dynamic cyclone doesn't necessarily take out our grit fraction though. So grit is like little pieces of sand and eggshells and glass that float along with the organics. They're hard to remove because they're smaller and they might have a similar density to the mixed liquor. And if they get into your process, they will fill up your tanks eventually and take up space and wear out your equipment, and you'll have to have shutdowns to remove it all. So you can see in the picture on the left inside a digester, it's just got like meters high of grit that's piled up in there over the years. So that's why it's important to take out at the front end. So So a hydrocyclone is similar to like an industrial dust removal system or a dust system you'd see at a wood shop, where it'll spin the mixed liquor around, and in the middle of the vortex where there's not as much motion, it'll be easier for things to fall out of suspension, and those heavier pieces of grit will be able to come out there. Even though they're similar size as the organics, the density will separate them out here in the hydrocyclone. Similar principle, but happening in a vertical direction, is a gravity separation tank. So very similar to a clarifier for wastewater treatment. In a quiescent environment, that grit is going to eventually settle down by its density difference, and it can be scraped off the bottom and disposed. And then lastly, another approach is to let everything go through into the digester and have scrapers and pumps at the bottom of the digester that are piping that material off for disposal. So that's it for pre-processing. Next, we're going to send our nice clean stuff into our digestion tank for wet AD. For dry AD, we wouldn't have done those steps, and we'd be sending a lot of our contamination in and sorting it at the back end. So that's what the next video is going to look at, the digestion process itself.